Hello students. Today we will discuss next chapter, chapter number 6 in paper second, differential equations. In HSC board examination, the weightage of this chapter is 8 with option, and the point contained in the chapters are, first points are differential equation. That means what is the definition of the differential equation. Second, order and degree of the differential equation. Shortly, the differential equation can be write d dot e. Third is formation of differential equations. Fourth is solution of differential equation. And fifth, the type of differential equations. And last is most important, application of differential equation. In this article, there are different type of applications in physics, chemistry, biology as well as economics. Now, today we will discuss only what is meant by differential equation, that is first point, as well as what is the order and degree of the differential equation. Now, first point is differential equation. Equation which contain the derivative of function is called differential equation. Equation which contain the derivative of function, that means equation consists the derivative term. For example, d2y dx square, which is the second order derivative of y with respect to x, plus 4 into dy by dx plus 5y is equal to 0. Now this is the equation, but this equation consists, this is the first order derivative term, derivative of the function, which is second order derivative term. Such a type of equation is called as the differential equation. We take second example. 1 divided by dy by dx is equal to 2 sin x into dy by dx bracket square. Now also this equation consists derivative term. Therefore, we say that this equation is differential equation. Now sometimes we write y double dash triple dash plus 2 into y double dash plus 3y plus 5 is equal to 0. The meaning of this equation is third order derivative, that means 3 d3y dx cube plus 2 second order derivative of y dy by dx square plus 3y plus 5 is equal to 0. Now which is also differential equation, but here write in another form. y1 is the first order derivative, y dash, y double dash is second order derivative, y triple dash is third order derivative. In this way, the equation which consist or contain the derivative of the function, the term derivative of the function, is called as the differential equation. Now, we take the next point. Second point is order and degree of the differential equation. The order of differential equation is highest order of derivative appearing in the differential equation. We take the example dy by dx bracket square plus d2y by dx plus 3y is equal to 0. Now this equation is the differential equation because This consists derivative term, first order derivative bracket square plus d2y by dx square, second order derivative plus y is equal to 0. That means which is the differential equation. Now we find the order. It is the order of the differential equation. The highest order derivative term. Here first order derivative term as well as second order derivative term consist in this equation. The highest order derivative term is d2 by dx square. That means second order derivative term. Therefore, the order of differential equation is 2. Order of differential equation is 2. And now the next point, degree. The degree of differential equation is the power of the highest order present in the equation. Here d2y by dx square is highest order derivative present this equation, and its degree, here the indices is not right, therefore 1 is the indices. That means the degree of this term is called as, or power of this term is called as the degree. Then degree of differential equation is 1. That means first find the order of the differential equation. That means a term highest order derivative consists in this equation. This order is called as the order of the differential equation, and degree of this, the power of the highest order derivative present in this equation is called as the degree of the equation. We take another example, second example, dy by dx plus d2y by dx square bracket is to 3 plus 5y is equal to d3 by dx cube. Now here the first order derivative, second order derivative term, third order derivative term. First we find the order. The highest order derivative is third order. That means order is 3. And its indices is 1. Therefore, degree is 1. Now third example, under root 1 plus dy by dx is equal to d2y by dx square. Now here the degree of the differential equation is a positive integer. Most important point, the degree of differential equation is always positive integer, not a fraction, 1 by 2, 3 by 2. Here under root 1 plus 1 by dy by dx is equal to d2y by dx square. That means here the power of this term is fraction, and taking square on both sides, 1 plus dy by dx is equal to d2y by dx square bracket square. Then what is the degree of this differential equation? This equation consists second degree derivative term, that is d2y by dx square. Degree is 2. And order, the power of this term is also 2, then order is 2. In this way, very simple question in MCQ type questions ask what is the order and degree of the differential equation. We solve some example in exercise 6.1. Now the question is find order and degree of the following differential equation. First example in exercise 6.1 is d2y by dx square plus x dy by dx plus y is equal to 2 sin x. In this equation, The highest order derivative is this term, second order. That means order is 2. And degree is power of this term. Here power is not given, that means 1 is always power of each term. Then power is 1, therefore degree is 1. Answer is order is 2, degree is 1. Now we take second example. In exercise 6.1, second example is under root 1 plus dy by dx bracket square is equal to d2y by dx square. Now on left hand side, the power of this term is a fraction. Therefore, simplify this taking square on both sides. Taking square on both sides. Then left hand side is 1 plus dy by dx bracket square is equal to d2y by dx square bracket square, because taking square on both sides, this under root cancel. Now this equation consists highest order derivative term. Here first order derivative, its indices is power is 2, but which is not important. Here second order derivative, that means highest order derivative term is this. Therefore order is, highest order is 2 and degree is also 2. Now third example, dy by dx is equal to 2 sin x plus 3 whole divided by dy by dx. Now this example is not in standard form, because in right hand side numerator and denominator, left hand side only dy by dx. First simplify this equation is in this form, dy by dx, this denominator in left hand side, take this denominator is dy by dx is equal to 2 sin x plus 3. dy by dx into dy by dx is dy by dx bracket square minus 2 sin x plus 3 is equal to 0. Now this is the simplified differential equation. This equation consists derivative term, and which is the one and only one derivative term, the first order derivative. Therefore order is first, but the indices of this term is 2, therefore degree is 2. Next example, fourth example, d2y by dx square plus dy by dx bracket square plus 7x plus 5 is equal to 0. Now which is also simple example. Here dy by dx bracket square, some students can write the highest power is 2, therefore degree is 2. But derivative is first order. Here derivative is second order. That means we find indices or power of this term. That means order of this equation is second 2, because second order derivative term consists and its indices is 1, therefore degree is 1. Now, fifth example, d2y by dx square plus dy by dx plus x is equal to under root 1 plus d3y by dx cube. Now the left hand side consists d2y dx square dy by dx plus x, but right hand side the power of this total term is fraction. That means first by taking square this fraction can be eliminated because the degree want to the positive integer. Taking square on both sides, d2y dx square plus dy by dx plus x bracket square. We cannot expand this bracket. Only simplify right hand term 1 plus d3y dx cube. Now here second order derivative, first order derivative, third order derivative. That means highest order derivative term is d3y dx cube. Therefore order is 3 and its indices, that is degree indices is 1, degree is 1. Now next sixth example, y triple dash bracket square plus 3y double dash plus 3xy dash plus 5y is equal to 0. Now which is also differential equation but which is in different form. Y triple dash means d3y dx cube bracket raised to 2 plus 3 y double dash means second order derivative of y d2y dx square plus 3x into y dash means first order derivative dy dx plus 5y is equal to 0. The highest order derivative term is third order, that is order is 3 and degree its power is, the maximum power is 2, that means degree is 2. Now next example, seventh, 1 plus dy dx bracket raised to square bracket raised to 3y2 is equal to 8 into d2y dx square. Now in left hand side the power is a fraction 3y2. Now this power want to positive integer. That means taking square on both sides, then 1 plus taking square on both sides, left hand side 1 plus dy dx bracket square raised to, we take it square 3y2 raised to 2, that means 2 to cancel, only 3 is equal to square of 8 is 64 and d2y dx square raised to 2. Again here the degree is 3 but derivative is first order. That means we cannot find degree and order from this term. The highest order derivative is d2y dx square. That means order is 2 and degree, the power or indices of this term is 2. That is 2 is the answer. Now we take last example. Example number 8. d3y by dx cube bracket raised to half minus dy dx bracket raised to 1 by 3 is equal to 20. Now this example is complicated problem to find the degree and order easily, but because the here power is 1 by 2 fraction, here 1 by 3 is fraction. Such a situation we take the LCM of this 2 and 3 and take the power of this. That means product of 2 and 3, 2 into 3 is equal to 6. And first write the highest derivative term in only one side. That means d3y divided by dx cube bracket raised to 1 by 2 is equal to 20 plus dy by dx bracket raised to 1 by 3 raised to here power is 1 by 3 only this term is left hand side, and then taking power on both side is 6. Taking 6 power on both side, then d3y dx cube bracket raised to 1 by 2 raised to 6 is equal to 20 plus dy by dx bracket raised to 1 by 3 raised to 6. Its power is d3y dx cube raised to 1 by 2 into 6 is 3 is equal to 20 plus dy by dx bracket raised to 1 by 3 raised to 6. This term cannot expand because here first order derivative, third order derivative. From this relation we find the order and degree of the given equations. Here the degree is 3 and order is also 3. Okay.